Good morning, we are Team 2 and we are going to present our final challenge report on energy efficiency. The main objective we have was to search information about several vehicles to compare, analyze and evaluate their impact, helping us choose the safest and better eco-friendly environmental one.
Now for the first part, we're going to explain the energy required and the calculations for the efficiency. Now, as our physical model, which is a bicycle used by a person, as we can see in this picture, here is the pinion connected to the wheel, and here is the star or the plate with the connecting rod and the pedal. Now, the calculations for the ideal energetic consumptions, we need to calculate the work and the metrical development, and with that we can get the ideal consumption that it is 5.35 megajoules per 100 kilometers. Now, as the real consumption, we need the kilocalories divided by the kilometers, and that gets us the 2,000 kilocalories per 100 kilometers, and the real consumption in megajoules is 8.3 megajoules per 100 kilometers. And to get the energy efficiency is the ideal consumption divided by the real consumption, and it is 63.99%.
Now, when talking about energetic efficiencies of other vehicles, we're going to start with the fuel combustion vehicles. Let's start with the Vespa GTS 300 SuperTech. Now, this one is regulated by the Euro 5 law. So let's see. The consumption, the real consumption is 31.2 kilometers per liter. And an ideal consumption of 1 liter of gasoline is of 8.9 kilowatts hour over 100 kilometers. Making the conversion, the calculations, we can say that the real consumption of the Vespa GTS is of the real consumption is 28.48 kilowatts hour over 100 kilometers, and the efficiency is of 31.25%.
And then, so we can get the efficiency of a Suzuki Swift GLX with automatic transmissions, we have two data, the real consumption and the ideal consumption. The real consumption of the Suzuki is 25.75 kilometers per liter, and 1 liter of gasoline is 8.9 kilowatts hour per 100 kilometers. And then we have to convert the kilometers per liter to liters per 100 kilometers. And then we multiply it by the ideal consumption, so we can get the real consumption of the car, which is 34.71 kilowatts hour per 100 kilometers. And this way we get the energy efficiency, which is 25.74%.
So we can get the electric efficiency, energy efficiency for electric vehicles. We chose Tesla Model 3 as it has a worldwide impact. All of this information is given by Tesla. We get by Tesla the real consumption, which is about 0.275 kilowatts hour per million miles, just out of practicity. We get the ideal consumption by dividing the battery by the ideal range, which gives us 0.209 kilowatts hour per mile. We divide this to get around 0.76, which gives us an energy efficiency of around 76%.
Now for the hybrid cars, we choose the Toyota Corolla, and making the right calculations, we have a consumption of 18.69 kilowatts per 100 kilometers. And for the energy efficiency, we have a 47.62%, giving us a lower carbon emissions, and over the years they have been more common in Mexico, improving the fuel efficiency while helping the air quality and creating a positive impact.
Now, let's talk about the global analysis, the data that we have. Let's start with the energetic consumption and efficiency of our means of transport. As we can see, the gasoline vehicle has the highest energetic consumption of all of the vehicles presented, and the bicycle has the lowest. Now, in the part of the efficiency, we have shocking results. Uh, we have that the bicycle is not the most efficient means of transport. Why? Because the model that we use, the person that was riding the bicycle was not as fit as other people might be. So the calorie consumption was higher. So the efficiency of the bicycle was lower. And the electric vehicle has the highest efficiency of all of the means of transport, in specific that model, because well, the data given to us by Tesla implicated that most of the electric vehicles have from 70 to 80% of efficiency. But let's see the behind of all of this graph.
Now, this graph shows the data of the use of each kind of transportation from 2002 for 2022. We can see that, for example, hybrid or electric cars have been more common, but gasoline cars still remain as the more used way of transportation over the years.
And here, this graph shows the use of vehicles since 2002 to 2022. We can see that the gasoline vehicle have been the most used since 2002. And here we have that since 2016, the new emerging kind of transportations, which is electric vehicle and hybrid vehicle.
When talking about the specifics of the means of transport, we can see energy consumption in kilowatts hour over 100 kilometers, so the comparison is real. Then we have the percentage of efficiencies. As we can see, as I told you, the electric vehicle is the highest one. And the use or the units of that kind of transport from 2002 to 2022. And we have, of course, increases. You can see the electric vehicle has the most increase, meaning there is a higher production and more people are buying them.
So here we have a tabular interpretation of the vehicle usage and sales increase since 2002 to 2022. We can notice that electric and hybrid vehicles do not show up on the table until 2016. This is due for the implementation of new technologies for commercial usage. By this table, we can calculate the tendency lines and the equations for the growth of these vehicles. While most of these vehicles use linear equations, electric and hybrid opted for exponential and polynomial equations respectively. By this, we can do projections for the usage and sales increase for 2030. We can see a very big increase for gasoline vehicles, while electric vehicles compared to 2022 have a massive increase from 8,000 units to almost 500,000 units.
When we're talking about the holistic comparison, we can make a range from the lowest to the highest carbon emissions, and of course from the most to the least environmentally friendly. When talking about the bicycle, we can say that when you're using the bicycle, there's no such thing as a carbon emission or as a pollution. But the whole industry that makes bicycles and materials and all of the production is very pollutant. And of course, the gasoline car is the most pollutant from the industry that makes them to the usage. And all of the in-between, we are seeing that things like the lifespan or efficiency or the type of fuel or energy that they use are variables that make this range. And as a conclusion, we all came to the understatement that we need to continue to create more clean energies, and because we're engineers, we have the responsibility to include sustainability in all of our projects. And yeah, that can lead to the evolution of the transportation industry and a brighter future. These are our references. They're a lot, as you can see. And that was all from our part. Thank you so much for your attention.
Well done, team. I have a few questions. When you present all the percentage of views and how they are increasing along the time, why do you think that we have in all of them values higher than 100%? Because you present like 400, 200, huge
Increase.
numbers. If you go to all your first
Like the
slides,
percentage of decrease.
Like the table, the units.
for example, with the table, we can see it. No, the previous one there. There you have the increase, that part there. You have increased percentage, and you have like 1,000, 2,000, 400. What do you? How can you interpret that information from there?
Well, we used both the latest value and the earliest value, and we followed the formula to the increase. So that's the value that gave us how many times did this increase.
But that means that we are considering just new vehicles of that type that are going out, that we're buying, or that the people is selling, or what is exactly that percentage?
Oh, that percentage, for example, on almost every vehicle, that percentage indicates the usage. Like we go through the reports for vehicle usage for 2002 and 2022. We do calculations to know the increase in percentage. Like we divide the.
When you mentioned that bicycles weren't actually like the most efficient one, you mentioned that it was because of the kind of people that is using the bike, right?
Yeah.
Yeah.
So, an average people, let's suppose you're a teacher that doesn't know how to ride a bike, how efficient or how can you calculate something like that?
Well, it starts with the calorie consumption of the person using the bicycle. So you can see our person wasn't very fit, so the calorie consumption was way higher. So it means that the efficiency lowers. But in a fitter person, the bicycle would be the most efficient by far.
Okay. So your result is just telling us that not for all the people we can consider it like the most efficient one.
Because there are so much variables when calculating efficiency and energy consumption. We use as you can see, very specific cases. So we can showcase not only a general comparison, but a very specific one.
Even the specific one, and we also need to consider the diameter and the number of feet that the plate and the pinion has, and well, that gives the ideal energetic consumption.
As well as the general force,
Yes.
because it's not the same when you apply a lot of force, it's way more efficient.
Yes.
Okay. Just one small comment. When you're presenting, like in this case, try not to have like all the information there. Remember that in a presentation you're presenting your results, so it's not necessary to have like the whole procedure for everything, because you are going to end with a bunch of slides that yes, they are useful, you use it to get your conclusions, but it's not the idea like to present everything there, okay?
Okay, just a suggestion. In the last part, you show some tables that need something like a description, because actually they don't have any unit. So be careful with that.
The units?
The unit and about need some description.
It's like you just have the chart without any further information. Like,
No, the next table. For example, this one. I don't know what you want to show.
These ones are the units registered by
I know you because you explained it, but this table needs a unit. Just a suggestion, and probably needs a very little description. Will be best. Just one question. You said that the bicycle is not a more efficient vehicle. If the money were not a problem, what would you choose for mean of transportation?
For means of transportation, well, it depends on a lot of things. When it was not a problem, personally, I would use an electric vehicle because of the distances that I have to travel.
Okay. Yes. All of you are agree with.
So, yeah, in my case, like Hannah said, there are a lot of variables to take into consideration, like the walkability of cities, implementation and adoption of vehicle usage. There are some cities that are more walkable, than others, like in Europe. In Europe, it's pretty common to use bicycles to go by foot to go everywhere. But in cases like Mexico City or Puebla or any other city in Mexico, the usage of vehicles is standard. So yeah, in terms of energy efficiency, electric vehicle is the most efficient. But in terms of environmental impact, I would choose a bicycle
Okay.
for just practicity, if there's a possibility.
Okay. Thank you. That's it.
Thank you.
Thank you, Tim.
Thank you.